Hello everyone and welcome to the Fears at Home Laboratory. I have my two lab assistants. I have my buddy Cole here and I have my little girl Rose here. They're going to be my helpers. So today we are going to investigate convection currents. So if you remember from your reading, convection is a type of heat transfer with fluids. You can put it down. So fluids is any kind of air or gas and liquid. So liquid is a fluid, air is a fluid, okay? So they're both fluids. So we have some fluids here. We have 4 jars filled with water. The blue ones, as you may have guessed, are full of cold water, and the red ones, as may become apparent now, are full of hot water. So the way convection currents work is based on density and temperature. If you remember from your reading, heat, how hot an object is how fast the molecules are moving. So a warmer object, the molecules are going to be moving around, bouncing around, and taking up a lot more space. So they're going to be less dense. And if you remember what less dense objects do, or less dense liquids and fluids do, less dense fluids rise. They like to go up because they're light, right? They take up less space, there's less mass, less molecules jammed into the space, so they like to rise. Whereas cold substances, the molecules huddle together, they don't bounce around as much, they're not as fast, they come cramped together, so there's a lot more mass crammed in the space, so they feel heavier and they're more dense. So cold substances are going to sink, hot substances are going to rise, and we're going to show that today with our convection jars. All right, so hopefully this will work. So our first set of jars is we're going to have cold on bottom and then red on top, and we're going to use my skills in the dark arts like we did last time. I'm going to take my paper and place it on the jar. Okay, is it on there solid, you think? All right, I'm going to turn it over. Hopefully that'll work. All right, so as you can see, the hot water's staying in there because there's more than 100 pounds of air pressure, remember, pushing up on this little jar right here, on that paper. Oh, got it just in time. The seal just cracked. Okay, so now what I'm going to do is I'm going to make these two fluids interact with each other. What do you think is going to happen when I pull this piece of paper out? Let's see if I can get it. Oh, am I going to get it, Cole? Yeah, oh yeah, oh yeah, oh yeah. Hey. Come on, paper. Don't rip. Don't rip. Oh, it's trying to rip. Don't rip. Ah, got it. Okay, so where did the red fluid go? The red fluid's trying to stay up, right? Where's the cold fluid? The cold fluid's staying down. And that makes sense. Hot air and hot water and hot gas and hot whatever wants to rise. Cold wants to sink. So the only place that they're interacting is right here. And if you look really close, you can see a little line of purple, okay? And they're gonna stay this way until the temperatures equalize. Eventually what'll happen is this hot will cool down, this cold will warm up, they'll both be at the temperature of the air, and then they'll start to mix. So I'm gonna, as gently as I can, slide this one out of the way so that you can see, all right? And I'm gonna bring my hot one in. Now what I'm gonna do is I'm gonna reverse it. I'm gonna take my cold and I'm gonna put the cold on top. So my cold buddy, I want you to put the cardboard right on top of the cold. Just like that, right on top. Perfect. All right. So we have to, hopefully this will work. I'm gonna get it really close to the edge. All right. Come on, baby. All right, so what I'm gonna do, okay, now, what do you think will happen? Make your prediction. What's gonna happen when I pull the card out? Let's see. Let's do it a little faster this time. Okay, now notice. Watch the fluids. Can you see them interacting? See how the red is turning purple? Right? The colors have mixed up. Isn't that cool? Now, why did that happen? Well, that happened because the cold wants to sink, the hot wants to rise, so they mix together. And if I can look closely, I can kind of see the currents flowing in there. Okay? So this happened because the warm, low-density water wanted to rise. The cold, high-density water wanted to sink. So when they got to interact with each other, they mixed up. Okay? So they turned purple. All right? Remember, red and blue make purple. Okay, so this happens in real life. This convection happens in real life, but we don't see it necessarily as purple and red, right? So right now, you are currently in a fluid. That fluid's called our atmosphere. And our atmosphere is constantly swirling and churning, right? So the last couple of days has been beautiful. But you can see there's some clouds coming in, there's some wind, and tomorrow there's gonna be big thunderstorms. That's happening because you have warm air and cold air interacting, just like you have warm water and cold water interacting here. The movement of the fluid we feel is called wind. Okay, so we feel it as wind. We also see it in the oceans as ocean currents. That's happening because of the different temperatures. You have the hot, low density wanting to rise, the cold, high density wanting to sink. Okay. And with that, I think we're going to close this lab. Thanks for your help, Mr. Cole. Say bye, everybody.
Bye.
All right. Bye.